Welcome to emstatonline. Today we are going to see permutations. The ways of arranging or selecting smaller or equal number of persons or objects from a group of person or collection of objects with due regard paid to the order of arrangements or selection called permutation. Fundamental principles of counting, multiplication rule, if certain things may be done in m different ways, and when it has to be done a second thing can be done in n different ways, then total number of ways of doing both things simultaneously is m into n. Addition rule, if there are two alternative jobs which can be done in m ways and in n ways respectively, then either of two jobs can be done in m plus n ways. And is multiply, and implies multiply, or implies add, addition. Next one is factorial. The factorial n written as n factorial or n this one represent all product of all integer from 1 to n, both inclusive. So n factorial equal to 1, yeah, n minus 1, n minus 2, and etc. 3, 2, 1. Example 3 factorial, that is 3 into 2 into 1. And 0 factorial is equal to 1. Number of permutation when R objects are chosen out of n different objects. That is n p r. Consider the problem of finding the number of ways in which the first R ranking by secured by n students in a class, as one of the n students can secure the first rank. The number of ways the first rank is secured in n. Second rank n minus 1 student. Left, the second rank can be secured by one of them, and different possibilities are n minus 1 ways. So npr, that is equal to n into n minus 1 and etc. n minus r minus 1, which can be written as n into n minus 1 and etc. up to n minus r plus 1. Otherwise, we can write n factorial divided by n minus r factorial. So npn, that is n factorial divided by n minus n factorial, that is n factorial is n minus 1 0 factorial. So npn is n factorial. So an example. Evaluate 4p3. Solution. n p r, that is n factorial divided by n minus r factorial. This can be written as NPR, which implies 4P3, that is equal to 4 factorial divided by 4 minus 3 factorial, that is 4 factorial is 4 into 3 into 2 into 1 divided by 4 minus 3, 1 factorial, that is 1. So that answer is 24. Next example. If NP4 equal to 12 into NP2, then find N. Solution. NP4 equal to 12 into NP2. That means NP4, N into N minus 1 into N minus 2 into N minus 3 equal to 12 N into N minus 1. Therefore, N minus 2 into N minus 3 equal to 12. As there are two factors on LHS with the difference 1, we find two factors of 12 with the difference 1. So N minus 2 into N minus 3 equal to, we can write 4 into 3. So N minus 2 equal to 4. N minus 2 is equal to 4. So N is equal to 6. Next example. If NP3 is to NP2, that is equal to 3 is to 1, then find N. Solution. NP3 is to NP2. NP3 is to NP2 equal to 3 is to 1. Then we can write NP3 by NP2 equal to 3 by 1, which implies N into N minus 1 into N minus 2 divided by N into N minus 1 equal to 3. So N minus 2 equal to 3, N is equal to 5. Next example. If M plus N P2 equal to 56, M minus N P2 equal to 30, then find the value of M and N. Solution. M plus N P2 equal to 56. This one we can write M plus N into M plus N minus 1. That is equal to 56. So M plus N into M plus N minus 1, we can write 8 into 7, because that number difference 1. So M plus N equal to 8. is equation number 1. Similarly, m minus n p2 equal to 30. This one m minus n minus 1 equal to the two numbers difference 1, that is 6, 5. So m minus n equal to 6. So adding equation number 1 and 2, we get 2m equal to 14. So m is equal to 7. Substitute m is equal to 7 in equation number 1 when n is equal to 1. So m is equal to 7, comma 1. Next example. If 5PR equal to 60, then find R. Solution. Given 5PR equal to 60, that is 5 factorial by n minus r factorial. n is 5, so 5 minus r factorial equal to 60, which implies 5 factorial, that is 120 by 60 equal to 5 minus r factorial, because 5 factorial is 5 into 4 into 3 into 2 into 1. So this one we can write 5 minus r factorial equal to 2, that is 2 factorial. So 5 minus r is equal to 2, then r is equal to 3. Next example. The number of ways the letters of the word computer. Solution. Computer consists of, the word computer consists of 8 alphabets. To form the word, this alphabet has to arrange. It can be 8 different ways. So 8 P8 equal to 8 factorial, that is npn, that is equal to n factorial. So 8 factorial, 8 factorial, 8 into 7 into 6 into 3, 6 into 5 into 4 into 3 into 2 into 1. So calculator 40320. Next example. The number of arrangements of the letters the word failure, so that vowels are always coming together. Solution. The word failure, there are 7 alphabet in which 4 are vowels. As we require all vowels together, we will make one group of vowels. Our remaining 3 consolidate of 3 groups. Now we have to arrange these 4 groups. It can be done by 4 factorial different ways. The 4 vowels can arrange with themselves 4 factorial ways. So the number of arrangements vowels together 4 factorial into 4 factorial, that is 24 into 24. Next example. Ten examination papers are arranged in such a way that the best and worst papers never come together. Find the number of arrangements. Solution. As a number of arrangements, such 2 best and worst papers can never be together. That means total number of arrangements ten papers minus number of arrangements of best and worst paper together. The total number of arrangement 10 papers. So 10 papers that has to arrange, so it can be done 10 factorial different ways. The number of arrangements of best and worst paper together, it can be in a group of such first, second, or second or third or fourth, and so on. So we'll make one group of best and worst paper. Now remaining 8 individuals. So paper are considering 8 different ways. Now there are total 9 groups. As to arrange, it can be done by 9 factorial ways. The 2 papers best or worst can rearrange with themselves is 2 different ways. Themselves 2 different ways, that is 2 factorial. So number of arrangement of these 2 papers together So 9 groups, so 9 factorial into 2 factorial. That is 9 factorial into 2, because 2 factorial is 2. So the number of arrangements of 2 best and worst paper can be never together such 2 best and worst paper can never be together. That is equal to total number of arrangements of 10 papers minus number of arrangements of best and worst papers together. That is equal to 12 factorial minus 2 into 9 factorial. That is 10. We can write 10 into 9 factorial minus 2 into 9 factorial. So 9 factorial will be taking outside. So 10 minus 2. That is 9 factorial into 8. The answer is 290.